Hi, my name is Chris and I'm looking for assistance with Vectorworks to automate a process. Let me explain what I'm looking to do. The technical name for what it is I'm trying to do is Conic Lofting. Conic Lofting is a mechanism used in extracting curves, complex curves for boat hulls or aircraft fuselages. As you can see here, there's a bunch of math, bunch of theory on how to extract these curves, and very little information out in the world, including hard textbooks on how to do this. I found a couple of places that helped me understand the process, so I want to explain that to you today. If you look at the aircraft fuselage, it is longitudinal, where throughout the longitudinal axis of the aircraft you'll see slices. These slices are referred to in aircraft as bulkheads. And what I want to do here is I want to zoom in to show you one of these bulkheads. The bulkhead I'm about to show you is basically the bulkhead behind the passenger cabin. This is a scale model that I'm trying to extract from a TIFF file. That's why this process is taking so long. It's very resource hungry. And I'm doing it on a laptop. Alright, now that we're zoomed in, you can see this bulkhead has several elements to it. The top half of the fuselage has a curve. There's a straight side section here, and another curve down at the bottom. And then there's another half to this. You just mirror this, and that would be that bulkhead for that particular longitudinal station. So what I'm going to talk about today is just the upper quadrant, or the upper curve. Each curve, the upper curve and the lower curve, have to be conic lofted, and to generate that curve in order to produce this bulkhead. So what I'm going to do to free up some resources is I'm actually going to close this dock. And here is a representation, for instance, of that curve. We have a to C line. That A to C line is the horizontal width of half of that fuselage. The B to C line is the vertical height of that curve. And in conic lofting, if you look it up on the web, there is a S point, or what they refer to as a shoulder point. What I did is I pulled a line between A and the S point and B and the S point, and I extended those out to the edge of the box to assist in drawing. You'll see how they assist me in a moment. Additionally, I draw a line from C to the S point just as a reference, so if in case my green lines inadvertently get moved, I can still get back to my S point. Now what I'm going to do is I'm going to draw a few lines and show you how I actually create my curve. But before I do that, I want to note that there are hash marks on the left and on the bottom. What I do is I use a duplicate along path. I create a hash mark, a single hash mark, and I duplicate that 64 times along that length. I also do that 64 times along its height, but I would like to increase that to about 128 or 256 hash marks and have this automated process calculate this curve for me. By increasing the number of hash marks, you increase the resolution of the curve, and it just makes for a better CAD file for aircraft. What I'm going to do here is I'm going to pull a few lines from a few different areas. First of all, just to keep my S shoulder point, I have a line from C to S, but I have another line here that I've laid over top of it. And so now that C point is just a reference. It's going to be held by my red line. My blue line I'm basically going to use as a tool to extract my conic points, and I'll show you that now. In addition to that, so I don't move my green lines, I've pulled a black line over my B to S and my A to S. Now, what I do is normally you take this C to S line and you pull it basically to each and every one of these hash marks. I'll start at the first hash mark. I'm going to have to zoom in for you to see this. But how this works is you start at the first hash mark. You take the A to S line and you snap it to that intersection. Then you take the intersection of the C and B line. Then you take the B line and you snap it to the intersection of the A to S line. Excuse me, A to C line. And just because it's so close to the edge, I'm going to zoom in on this area down here at the bottom. To complete this, I'm actually going to take and zoom in even further because, like I said, it's so close to that red line. And now you can start to see the separation. So what I'm going to do is go back and select my A, hold the Shift key, and pull that till it hits that B line. That's my first point, so I'm going to put a locus. And I'm going to fit the page. Alright, so I've created my first locus point. In an effort to try and speed this up, I'm going to skip several points. It'll still create a curve, but it'll have less resolution. Okay, so there we go. Here's my next point, and what I'm going to do again is take my A line and snap it to the intersection of the C and B. I'm going to take my B line and snap it to the intersection of A and C. And then I'm going to, with the Shift key, stretch my line to hold the angle. Till I hit my B line, and there's my next locus point. Then what you do is you continue this process. Put another locust point. Move to the next. Back to my A line. Hold the shift key and stretch it to the B line. Another locust point. And like I said, you would do this for both the horizontal and the vertical hash marks. Very time consuming. It takes me usually 2-3 days to work through it, depending on how busy I am. And it's tedious, and if I'm tired or something, I could get one of these slightly off, and it just, oh, pain in the butt. Hold the shift key, drag that out, another locust point. Okay, by now I hope you can see all the locust points. I mean, they're very far apart, but you can see that they're starting to create a curve. And when I get done putting all these locust points in, I take the polyline tool, start down in the corner, and I click all the locust points. Again, accuracy is a big deal with me. And you know, there's so much room for error if this process is not automated. Double click to close it. Make that a non-solid. And as you can see, you can extract a curve. What I'm trying to do is automate this process. Anybody that can help me, I would greatly appreciate it. If you have any questions, you can contact me at chrisknechtel@hotmail, ChrisKnechtel @hotmail.com. Thank you.